Today we will discuss the numerical methods. Which is only for GATE exam. First we will discuss the root finding methods, in which there are two types. One is the bracketing method and second is the open methods. So we will discuss first the bracketing methods, in which first is the bisection method. It is very simple and easy to implement. It is also called as the interval chopping. So what is the procedure of bisection method? Consider the function f of x and it has root x. So it is very simple method. Consider 2 points A and B such that the real root lies between the two values. So means real root lies between this value. So what is the condition that real root lies between two values? If the function value has the opposite signs, means f of a and f of b has the opposite signs, means the function value changes signs, means at some point in between the 2 points the function value must be a 0. So if the real root lies between a and b, or f of a and f of b has different signs, then update. So how can we update the x forward pointing? So simply we take the average in the bisection method. So suppose the average of these two is sum here. So this is our x, which is calculated from this. So after that, next step is, if suppose this is x1, so if f of x1 and f of a has different sign, suppose f of x1 and f of a has different sign, and it is happen in this case, so we assign b is equal to x1. We assign x1 value to the b and take the next update of the root, that is a plus b divided by 2, else if f of x1 and f of b has different sign, Then assign x1 to a and take x2 as a plus b by 2. Continuous this process until the we does not reach some threshold. How this is the stopping criteria used. The relative difference between the when the relative difference between the two iterate is lesser than some threshold, we are going to stop our iteration. Or we can check the function value. Either way we can decide the stopping criteria. Some important points about the bisection methods is it always converges, but it has the very slow convergence rate, and order of convergence of this method is equal to 1. Second, sometimes so when we do so after nth step size is b minus a divided by 2n. Third point is error at nth step in the bisection method is bounded by b minus a divided by 2 raised to n is less than or equal to secant raised to n. So in many times in GATE exam we ask the number of steps, calculate the number of steps required to reach the bisection method, and they provide the error. So this is the simple formula. By using that we can calculate the number of steps. If the number of steps are decimal value, it is not a integer, then always take the next integer. Okay, so this is the bisection method. Next, this is the first bracketing method. Second bracketing method is the false position method. So in a bisection method, what we have seen, just we take the average of the two values and it considered as the next update to the root, but we does not consider the whether it is near to the actual root or not. So in false position method, we actually what we do, suppose in bisection method, if our update one if our two values are such that a and b, we does not consider, because a is very near to the root, but we does not consider that. We just take average, and might be our next update here, then here, then here, and finally we convert to the solution, but it takes more iteration. So false position method, we actually derive such a method that considers the function value and the that considers function value and improves the convergence as compared to the bisection method. Suppose this is the function and these are the two values a and b. So in false position method, what we do, so we connect a secant or line between these 2 points a and b. So this value is f of a and this value is f of b. The one condition is remains same in false position method. We choose two values such that it has the opposite, means that it choose a and b such that function values have opposite sign, that is f of a and f of b must have opposite sign. So after that we connect 2 points and the line intersects the x-axis. That point is our next update, or next, it is the next value update for the root. So it is simple to calculate. So consider this line and this line and write the equation of the line. That is the, how can we, the slope of the line is same, so we can write the slope. So this value f of x1 must, f of x connects x-axis, so what is the f of x1 is equal to 0. And so how can we write the slope? So slope of this line first consider. So f of a minus f of x1, but f of x1 is 0, and this a minus x1 is equal to, and then the slope of this part consider. So means this length is f of b minus 0, this length is the b minus x1. So f of a upon a minus x1 is equal to f of b upon b minus x1, and if we solve, we get x1 is equal to a f of b minus b f of a upon b minus a, and that is the our update rule for the, this is the formula for false position method. So it also requires two values a and b such that function value has the opposite signs. We can update x1. After finding x1, we will also check the sign of the, after finding x1 we check the sign of x1, and if f of x1 and f of a has different sign, then assign x1 to b and use above formula for the next iterate. Else, if f of x1 and f of b has different sign, then assign x1 to a and use same formula above to calculate the next update x2, and continues this process until we reach. So in GATE exam they ask very simple problem, or they just, you don't need to converge up to the solution. They ask just applied two step, three step simple example will be there. But there are some disadvantages of this method. Suppose the function is something like this. Here we see that, because now the here we see that this is the new update for, then we the point consider, then this line which we consider, so it will finally converges to the solution, and it converges as faster than the bisection method. Okay, but if the suppose the function is something like this, okay, and these are the two values, our a and b. Sorry, this is a, this is b, this is f of b, f of a, and we connect, this is the line. So our next update will be here, that is x1. Then again we check the what is the value of the function at x1, and it is negative. And then again we connect these 2 points, and again we check the function negative, and it finally after some step it converges to solution. So sometimes if this function is very flat, then there might be slow convergence can happen in the false position method. So there are some properties or notes that is a false position. That is one. Order of convergence is equal to 1. False position. It has same convergence as bisection method. Both are the bracketing methods. The next we will discuss is the open methods. In open methods, the first method is the very famous Newton-Raphson method. I will write first the formula for the Newton-Raphson method, that is xn plus 1 is equal to xn minus f of xn upon f dash of xn plus 1. So some initial guess we require for the Newton's method. So x0 is equal to something, then we calculate the next value after our, until our convergence criteria is satisfied. So what is the Newton methods and how can we derive this formula? suppose this is our first initial guess. In Newton's-Raphson method, actually we take the slope at this point and extend the line from that slope. We consider this is the point x0 and f of x0 and some with slope is equal to f dash of x0, and this is our update for the root x1. So we know the slope point formula of line, which is y minus y1 equal to m into x minus so what is the here we know that so it is y1 is unknown, y0 sorry point x1 and this y minus this is y0 is equal to m into x minus x0. This y at this point the y is c y minus y0 is equal to f of x0 is equal to f dash of x0 into x1 minus x0, and for this y value is equal to f of x1. It intersects at the x-axis and therefore f of x1 is 0. So we can write f of x0 is equal to f dash of x0 x1 minus x0 and x1 is equal to x0 minus f of x upon f dash of x0, and this is the iterated formula for the Newton's-Raphson method, which is written above. This is the simple formula. I am telling you how to derive also because if you not remember the formula or if you have some ambiguity about the formula, you can just write down and quickly understand or derive the formula at that point, so you cannot make the mistake at the time of the exam. Actually we don't have much time at the exam, so it is better if we have remember the formula correctly. It will save our time. And second, some notes of the Newton's-Raphson method is the order of convergence of this method is quadratic, so it is converges much faster than the bisection and substitution method, and it is very dependent on the convergence is very dependent on the initial guess. There are some cases that it is not converges to the solution if the initial guess is very bad, so it is very dependent on the initial guess also. I will show some examples of that by graphically, and it converges if and only if this condition is satisfied. So converges if this condition is satisfied, then the Newton method is converges, or the method is converges, then this condition must satisfy. So there are some points of the Newton-Raphson method. So we will discuss some odd cases that will dependent on the initial guess and how it is converges or diverges from the solution. So consider this function. Am I right or not? Oh, okay. Consider this point. The slope. Okay. Then the slope at this point is Vd, so it will diverge. It will not follow. So first iterate is here x1. We take the slope. The second iterate. Sorry. That's what I think. The second update will be here x2. Then we will consider this point. Then we will take the slope at this point. It will again okay, we will modify somewhat. So suppose this is goes something like this. So our next iterate will be here x3, and then we will take this point, and if we take the slope of this point, then it diverges from the solution. It will not converges to the solution. So there are many such cases. We can show graphically that Newton method is diverges from the solution. And here we will see one thing, that the x1 value means the iterative value is completely changes. It's a new update, not like the bisection method. In bisection method, the root always lies in the brackets. So it is the it is full. It is we can assure that the method is converges, but it converges very slowly as compared to the Newton-Raphson method. If the initial guess is good, then Newton-Raphson is a very good method. It converges very fast to the required solution. The second open method is the secant method. So what is the main problem is the Newton-Raphson method is the calculation of the derivative f dash x, because the update formula is the xn plus 1 is equal to xn minus f of xn upon f dash xn. So sometimes this f of x may be very complex function, non-linear in sine, cosines, or very odd functions. So sometimes the differentiation of that function is very difficult. So in secant method, this derivative is replaced by the backward difference formula of the derivative. And that is the backward difference formula for derivative. And if we put the f dash x in above equation, then we will get the secant equation. So I will write in I xi plus 1 is equal to xi minus f of xi, and we put f dash xi. So f of xi minus 1 minus f of xi into xi minus 1 minus xi, and this is the update formula for the secant method. So in secant method we require two initial cases, xi and xi minus 1. If the two initial guesses are not given, then calculate by using any one of the methods as false position method, bisection method. You can calculate it. Use false position method for the better guess, better initial guess. So some illustration on the secant method. These are the two rules. Consider one of the points. This and xi and xi minus 1. So we connect the secant and we extend this secant, and just in what we do in Newton-Raphson, we take directly as a slope at this point and extend and see where the line cuts at the x-axis, but it is very difficult sometimes to calculate derivative, so we replace this slope by a secant, and if we take the point, this point as close as the xi, then secant method converges to the Newton-Raphson method. There are some similarities are between the false position method and the secant method, that both the methods are required two initial guesses, but they are different because in the false position method, if the function is like this, then the root is always lies between this a and b, but in secant it is not always possible that the root is always lies between the two xi and xi minus 1. The xi and xi minus 1 can be at the same side of the root, so it is sometimes secant method also not converges to the solution. It is possible, but false position method and bisection method always converges to the solution, but the convergence rate is very small. The order of convergence of the secant method, is 1.6 superlinear convergence. Is converges as less than the Newton-Raphson method, but it is convergence rate is better than the false position method and bisection method. So these are the 4 techniques of the root finding method that is most likely to ask in the GATE exams. We will discuss some examples of each method in the next video. So how the questions asked, or some typical exams of the Newton-Raphson method or Secant method, bisection false position method. Then we will, after that we will discuss numerical differentiation method. So that's it for today. If you have any doubts, you can write it in comments or DM me on the Instagram. I will tell you. Okay, thank you.